Hello everyone, a very good time. Today we are going to present paper number 9 of MCAUIS workshop co-located with MIPRw 2022. The title of the paper is Automatic Evaluation of Machine Generated Feedback for Multimodal Data. We will start the presentation with an introduction and survey of the existing works. We will move further to discuss the proposed method and metric, and then we will discuss the results. It is a newly defined problem where we aim to generate a feedback in a similar way how humans generate feedback towards multimodal input, and the task at hand deals with the automatic evaluation of the generated feedback. It is a new task where human intervention is required in general to evaluate the quality of the generated feedbacks. Our aim is to do that automatically. For that purpose, we have defined a new metric named AER score, that is automatically evaluated relevance score. For that, we use the pre-trained feedback generation model along with the proposed feedback evaluation model. Our contributions are twofold. First, we have proposed a novel system, Auto Evaluation Network or Auto EvalNet, which evaluates the machine-generated feedbacks for multimodal input data. Secondly, we have defined a new metric, AER score, that is automatically evaluated relevance score, which generates a score showing the relevance between ground truth comments and generated feedbacks. The aim is to use this metric instead of human evaluation. There are some existing work which evaluate the summary from multimodal input and which use embedding metrics and semantics similarity scores. However, they do that for already defined problems. Feedback synthesis is a new problem where the robustness of the model should be considered, which existing methods do not do. Hence, there was a need of automatic evaluation method, which we have done in the proposed work. The proposed method contains two models. First one is feedback synthesis model. Second one is feedback evaluation model. The feedback synthesis model has been adapted by Kumar et al. It consists of a visual and a textual encoder-decoder block that incorporates self-attention, and the outputs are textual context vectors and visual context vectors, which are used to calculate multimodal context vector, which is further used to generate the feedback. The second module is evaluation module, which evaluates the similarity of these feedbacks with the ground truth comments. We have used two paths, glove path and bird path. Glove path uses static embeddings which do not consider the context. However, it generates different embeddings for comments and feedbacks. Bird path considers the context of the vectors. It concatenates the embeddings of feedbacks and comments and generates a single vector. The two aforementioned modules have been shown in the following diagram. Here, input contains text and comments along with the image. The purple part shows the pre-trained feedback synthesis part, whereas the green part shows the proposed evaluation model. It has two paths, glove path and bird path. We have also designed three baselines containing only bird path, two bird paths, and ensemble of GRU along with bird part. As per the ablation studies, the ensemble of bird along with glove paths performed the best. The automatically generated scores were more in line with the human scores. That's why it has been implemented for the proposed method. Further, we define the relevance score denoted as AER score, which first finds the similarity between comments and feedback for every sample and then takes their weighted average to find the overall AER score. Taking weighted average ensures that the more relevant comments are given more weightage for the evaluations of similarity. Hence, it ensures to compute the humanness of the generated feedbacks in a more efficient way. The experiments have been performed on NVIDIA P5000 GPU having 16 GB virtual RAM on a system containing i7 processor. and Linux operating system. We had total 78,000 samples containing images, text, and comments. The comments were used as the ground truth comments, and the generated feedbacks were evaluated against them for their similarity. For evaluation, we have used the proposed AER score. We have also used human evaluation and compared the results of the two. Along with that, we have used rank-based evaluation matrices, where the comments had been sorted based on the number of likes, and recall and mean reciprocal rank metrics were used to evaluate them. Here are some sample results. It shows the text input containing text itself along with the comment and the text image. It also shows the generated feedback and the score generated by human evaluation, which is 0.28, and by AER score automatically, which is 0.37. We randomly took 20 samples and found the score generated by human evaluation and automatically, and observed the difference. The difference was of the order of less than 0.1 on a scale of 0 to 1. So more or less, automatically evaluated scores were in line with human evaluated scores, which approves the hypothesis that similarity between comments and feedbacks can be generated automatically using AER score in a similar way as human evaluation. In conclusion, the proposed method does not require human intervention to evaluate the similarity of generated feedbacks with ground truth comments, and automatically generated scores were in line with manually evaluated scores. In future, we plan to work on improving the relevance of the generated feedbacks as well as improving their syntax and semantics. With that, we conclude this presentation. Thank you so much for your attention.